picking back up to finish off solving trig equations in lesson 5.1.2. And I believe we are ready for number 6. If you recall, we're trying to get the trig function by itself so that we can say, okay, like the first one, sine x equals 1/2. Well, using our chart, using our unit circle, at what angle does sine equal 1/2, you know? And then these others, we've been working to get our trig functions by themselves. Now, our most recent one that I have up here, notice, if you look at the two above, which I don't have them right now in here, they are either all sines or all cosines, we could factor. This one was tangent and secant. We used the Pythagorean identity to make it all tangent, and then we were able to solve. Now, as we look at number 6, think about how you want to solve this equation. And I'm not going to say there's one right way to do this. I think I know what I would think. Just in terms of solving an equation. When you're solving an equation and you see a fraction, what do you tend to want to do? Multiply to get rid of the denominator. In this case, I have a denominator of sine x. So if that's divided by sine x, how are we going to get rid of that sine x? We're going to multiply by sine x. If I multiply the one side by sine x, we're going to multiply the other side by sine x. Now on the left, multiplying a sine x, when there's a sine x in the denominator, the sine x's will cancel, and we're going to have the cosine cubed x. On the right, cotangent x times sine x is just going to be cotangent x sine x. So we can do that because it's an equation. We can't do that when it was an expression, but because there's an equation, we can multiply both sides. We can do that. Jacob?
I don't know if you can see where you want to go or not, but could you turn the cotangent to cosine inverse?
Okay. It would definitely be helpful. That would be a helpful option, is we could take the cotangent and turn it into cosine sine, because there's something that's going to be helpful there.
Can you not turn the cosine over sine into cotangent because of the 3?
Right. You could, but it would be a cotangent and then it'd still be times cosine squared.
Okay.
So, yeah, you'd have 2 extras there. It's not that you couldn't, but you'd, yeah. Okay, so yeah, several different ideas here. I do like the idea in this case. Let's turn cotangent into cosine over sine. So we're using a quotient identity. So cosine cubed x equals cosine x over sine x times sine x. What's the advantage of turning cotangent into cosine over sine there? The sine on top can cancel with the sine on bottom, yes? And then I'm at the point of cosine cubed x equals cosine x. Thoughts? There's a good thought and there's a bad thought here, or a right thought and a wrong thought, maybe the words I should use. And again, think of it, it'd be kind of like the idea of having the equation x cubed equals x, if that's helpful for the moment.
Subtract cosine x, get on the same side.
Okay.
Get on one side.
Subtract the cosine x, get all on the same side. We're making the equation equal to 0 so that we can then factor. Okay. The wrong idea here is to say, okay, I want to divide by a cosine x, because when you divide a variable out, you're possibly losing answer possibilities, which is why I never say you always want to factor variables, not divide them out. So if I subtract the cosine x over, we'll write it in here. So then cosine cubed x minus cosine x equals 0. I already gave you a hint. I mentioned factoring, right? What do cosine cubed and cosine have in common? They have a single cosine in common. Yes, good. So if I factor a cosine x out, what remains in my parentheses? Cosine cubed divided by cosine is going to be cosine squared minus cosine divided by cosine is 1. What are your thoughts here? What do you see?
Set both parts equal to 0.
Yeah. We have two parts multiplying to equal 0. So zero product property says set each part equal to 0. So I'm going to have cosine x equals 0 or cosine squared x minus 1 equals 0. I'm going to have to debate, do I want to go back up there or do I just want to continue down here to the right? I might just continue down here to the right. We'll see. Cosine x equals 0 is cosine x equals 0, right? That one's piece of cake. We'll get answers for that in a moment. What about the cosine squared x minus 1 equals 0? To solve for cosine, you want to add 1, yes. So then I'm going to have I'm just going to kind of scoot it over here. That here we still have cosine x equals 0. Over here we have cosine squared x equals 1. When it's cosine squared x equals 1, what do I have to do? We're going to take the square root. We did that yesterday, right? What's the square root of cosine squared x? It's cosine x. What's the square root of 1?
1.
And? 1 and negative 1. So plus or minus 1. So we have cosine x equals 0, cosine x equals 1, cosine x equals negative 1. Let's figure out our answer possibilities. So this is the unit circle of the chart, right? When does cosine x equal 0? And this goes back up on number 2. Yesterday I drew a little chart, didn't I? I drew the quadrant circle so you could see it. So when does cosine equal 0? That's when x is 0. When is x 0? X is 0 at, gosh darn it, there we go, pi over 2 and 3 pi over 2. Okay. When does cosine equal 1? Cosine equals 1 at what angle? And that's over here at 0. So 0 degrees or 0 radians. When does cosine equal negative 1? Cosine equals negative 1 over here at pi. Again, that's using your quadrantal angles, yes? Now, these are our current answers. Before I move on to the next problem, though, we have one thing to consider. In the original problem, we had a fraction, correct? And what do you know about a fraction? Denominator cannot be 0. And what did we have in our denominator here? We had sine x in our denominator here, didn't we? So the idea is sine x cannot equal 0. Anything that would make sine equal 0 is not a possible solution. So this is like checking for extraneous solutions, basically. When you check for extraneous solutions, you're checking, is there anything that will make the denominator 0? So is there anything that will make sine equal 0? When does sine equal 0? So when is the y value 0? And when does that happen? Sine is 0 twice, right? At
0 pi.
At 0 and pi. So what that means, if sine cannot equal 0, x cannot equal 0 and pi. So what's that mean down here? Even though we got these lovely answers of 0 and pi, they don't actually work. Okay? So just kind of something to be aware of there. I don't really remember it necessarily happening a whole lot in homework, if at all, but it's a topic we need to watch out for whenever you're solving equations. If there are variables in your denominator, and they can make your denominator 0, then you need to possibly exclude answers there. Okay? So that was kind of a big bad problem there. Showing, we did some of the easier ones yesterday. This is definitely the more difficult one. Questions here? Excuse me. Let's try number 7 then. What's different about 7? And 8 for that matter. What's different about these bottom two problems compared to everything else?
It's like the 3x.
Yeah. Instead of it just saying, when does sine x equal 1, they're asking where does sine of 3x equals 1. So we just kind of have to think of slightly different here. Now, for the moment, the question I would suggest you ask yourself is forget the 3x for a moment, and just ask yourself, where does sine of x equal 1? In other words, basically, we'll come back and deal with 3x in a moment. At what angle, or angles, does sine equal 1? And where is that happening?
Pi over 2.
Okay. Pi over 2? Anyplace else? No. So the thought process here is that sine, sorry to write the wrong answer here, sine of pi over 2 equals 1, yes? And I really like that on purpose, because here's the deal. Our question is, when does sine of 3x equals 1? And what do we know? Sine of pi over 2 equals 1. So I've written two equivalent statements there, yes? But what I want you to do is set up the idea of 3x has to equal pi over 2 and do the math to solve for x. Does that make a little bit of sense there? So since we're trying to figure out 3x, we don't necessarily know 3x, so I'm going to think, okay, just where does sine of x equals 1? Well, that happens at pi over 2. So sine of pi over 2 equals 1. 3x and pi over 2 are in equivalent spots, right? Set them equal to each other. How do I solve for x? If it's 3 times x, one thought is to divide by 3. I don't much care for dividing by 3 when I'm going to have a fraction involved, so I would say dividing by 3 is the same as multiplying by 1/3. So then our 3 and 1/3 cancel. X equals pi over 6. Okay. So just when you have something other than x in there, figure out where your answer would be if it was just a regular x, and then set those pieces equal to each other. That's going to be my best suggestion there. Okay, one last example. 2 cosine of x over 2, that is x over 2, we have to have an x to solve this, right, equals negative square root of 2. What should be my first step here? We normally want to get our variable by itself. In these cases, we want to get our trig function by itself. So to get cosine by itself, I'm going to divide by 2. So then I have cosine of x over 2 equals negative square root of 2 over 2. Now, forget the x over 2 for a moment. Kind of like last time. Last time I said forget the 3x. I'm saying forget the x over 2 and just ask yourself, where does cosine of x equal negative square root of 2 over 2? Where does that happen? So let's start off with, where does cosine equal square root of 2 over 2? Forget the negative for a moment. Where does cosine equal square root of 2 over 2? And that happens at pi over 4. You guys need a little picture here? That happens at pi over 4. But is pi over 4 one of my answers? No, because that's in a positive quadrant. Do I want positive square root of 2 over 2? No. We need to consider where cosine is negative. What quadrants am I going to be looking at? We know we're not going to be looking at the all quadrant. We want where cosine is negative. So we're not going to be looking where cosine is positive. We want to look in the sine quadrant and the tangent quadrant. Does that make sense to you? Now go to the unit circle. Over in quadrant 2, what is pi over 4 up from the x-axis? And that is what? Okay, so 3 pi over 4 we're going to have to use. And down in quadrant 3, what is pi over 4 down from the x-axis? And that is 5 pi over 4. So these two pieces right here, that's where cosine equals negative square root of 2 over 2. But what were we really using? I'll go back to a different color here. We didn't want x, we wanted what? X over 2. So we've got to take x over 2. Like last time I took 3x and set equal to my answer of pi over 2. This time I've got to take x over 2 and set equal to my answers of 3 pi over 4 and 5 pi over 4. So x over 2 is equal to 3 pi over 4. And, I don't know, would it be safe if I write it as 2? X over 2 equals 5 pi over 4. If it's x divided by 2, we're going to multiply by 2. Okay, 2's cancel. What is 3 pi over 4 times 2? Three pi over 2. What is 5 pi over 4 times 2? 5 pi over 2. Okay. So you end up with 2 answers there. Okay. I'm going to put over here homework. It is page 511, I believe. 411, dang it. So close, only 100 pages off. You guys would have figured it out. 411, here's the 5, 51 to 62. And I told you guys yesterday, on the interval 0 to 2 pi. So if your directions give anything else, don't worry about it. Do what I've taught you, which is on the interval 0 to 2 pi. Okay? You guys have a little bit of work time.